We now determine the relative maximum and relative minimum of this given function g of x equals x cubed minus 9x. We find this is in the second derivative test. So in second derivative test, we say that for a function f of x, if f double prime of c, if it is greater than 0, we say that it is relative minimum, where c is the critical point, and we say that f double prime of c, if it is less than 0, we say that it is relative maximum. So this is according to the second derivative test. So for the function g of x, we should have the second derivative, which is already found here. So let's utilize this, that is g double prime of x, and this equals 6x. We will first find the critical point by plugging in g prime of x equals 0. So we have g prime of x, that is the first derivative, equals 3x squared minus 9. To find the c, we plug in x equal to, that is g prime of x equals 0. So therefore this becomes 0 equals 3x squared minus 9, and this implies 3x squared. We add 9 to both sides, we get 3x squared equals 9. That is x squared equals 3 when we divide both sides by 3, and we take the square root to determine the x, that is x equals plus or minus root 3. So we get two critical points. We see that one critical point, we can consider that as C1, which is positive root 3, and another critical point, we consider this as negative root 3. And so now we plug in these two critical points into the second derivative to determine its sign. Let's do that. So let me copy the second derivative here, that is g double prime of x. We have 6x. I'm going to consider each critical points one by one. First, I consider the critical point c1 equal to root 3. So I'm going to plug in into this in place of x. So therefore, it will become g double prime of root 3, and this equals 6 times of root 3. So this is basically a positive quantity. That is, 6 is positive and root 3 is also positive. So when you find the product of two positive numbers, you are going to get a positive number. So this is obviously greater than 0, and we say that this is relative minimum according to the second derivative test. So we say that this critical point C1 equals root 3 is a point of relative minimum. Now let's see how to find this relative minimum. All that we do is we take this critical number and plug it into the original function, that is into the g of x function. So let me do that. So first I write down this given function g of x, and this equals x cubed minus 9x. And now I plug in this critical number, that is this basically represents the x coordinate. So I can replace x equal to root 3 into this. So therefore this becomes g of root 3. This equals root 3 cube minus of 9 times of root 3. So we get root 3 cube is root 3 multiply itself with 3 times. So we can write down like this, minus 9 times of root 3. Root 3 times root 3 is 3. So this is 3 root 3 minus 9 root 3, and this gives negative 6 root 3. So therefore we can say that the coordinate of the relative minimum is x with y. That is, we can write down this as x comma y. This is for relative minimum. It is x comma y equals, in place of x we put this critical number, that is root 3, and in place of y we put this value, that is negative 6 root 3. So this is the relative minimum point. We will now plug in the second critical point, that is c2 equals negative root 3, into the second derivative to check if it is a point of relative maxima or minima. So let's do that. We have the critical point c2 equals negative root 3. So basically, this represents the x value into the second derivative, that is g prime of x, and this equals 6x. So plug in x equal to negative root 3 here. Therefore, this becomes g double prime of negative root 3, and this gives 6 times of negative root 3. So basically, this is a product of positive and negative number, and this will be less than 0. And according to the second derivative test, this confirms that it is a point of relative maxima, or we say that it is a point of relative maximum. So this C2 or X2 equals negative root 3 is a relative maximum. To find the relative y coordinate, we plug the C2 equals negative root 3 into the original function. So the function is g of x equals x cube minus 9 times of x. Now I plug in the second critical points, that is C2 equals negative root 3 into g of x. So therefore it becomes g of negative root 3, and this equals negative root 3 quantity cube minus 9 times of negative root 3. So this gives negative root 3 multiplied itself with 3 times, and then negative times negative is positive, so we get 9 times of root 3. We have a product of 3 product of negative quantity, so we will get negative, and root 3 times root 3 is positive root 3. I'm sorry, it is positive 3. So it becomes 3 times of root 3. That is negative 3 times of root 3 plus positive 9 times of root 3. And so this gives positive 6 root 3. So we see that the coordinate of the relative maximum. This is the coordinate of relative maximum. This equals x comma y, and this equals x basically is the second critical point, that is negative root 3 comma, this is the maximum, so it is 6 root 3. So this is the relative maximum coordinate. In fact, we can also give this in decimal representation. So the decimal equivalent is x comma y, and this equals negative 1.732 comma positive 10.392. So this is its decimal equivalent, and similarly we can give the decimal equivalent for the relative minimum. So here it is x comma y, and this equals, its decimal equivalent is 1.732 comma negative 10.392. So this is the relative minimum and relative maximum.